Okay, so my stinking video got cut off and I didn't realize it because I have it up high on the stand. So I plugged in, I was talking about plugging in x equals 0, that gives me -3. Plugging in 0 here gives me 3a. Plugging in 0 times the whole parenthesis is nothing, right? So ignore this stuff, that's way later. So 0 in here plus 0. And then that gives me a equals -1. So then I could, just like I did on the last one, I could go through and pick another convenient value, but I want to show you equating the coefficients because it's going to come up in future math courses. So first thing I did was distribute the a and distribute the x to get this simplified version of that equation. And then I grouped together anything that had an x squared, so the a and the b, and then I just wrote it in standard form, so the x squared and then the x and then the coefficient. Same thing over here. Since this one has an x squared, I want this one to have an x squared, and I can't just randomly throw in an x squared, so I need a 0x squared. And then I can equate the coefficients. So the coefficient of x squared over here has to equal the coefficient of x squared over here. That's how I got this equation. The coefficient of x has to equal the coefficient of x, so that was nice. That just gave me c equals 1. And then the constant hanging on at the end with no variable has to equal the constant. So from there I got a equals -1. And then with that a equals -1, I could plug in right here to find the b. b equals 1. And then I rewrote it with the a and the b plugged in right here. So basically, if I were to give these a common denominator to smush together, I would get that fraction. So we're going backwards from adding fractions together so that they now can be integrated, which is what you would be doing with this in the second half of calculus. So, hope that helped.